Hey, welcome back everyone. So my name is Zach Vines, and what I want to go over today is just the basic sort of an overall overview of how to conceptualize multiple regression. So in the previous video where we went over simple regression, what that entailed is that we had this line of best fit formula right here, where we have a scatter plot of x and y variables. So we're gathering data about something that we can gather, two dimensions on. Perhaps we're doing the relationship between weight and height. So we measure up a bunch of people, line them up, go, okay, what's your weight, what's your height, and we write it down and plot it on a point. Then our line of best fit that we think best explains the relationship between x and y, we map out using this formula right here, where y hat equals b naught plus b1 times x, where b naught is your y-intercept and b1 is your slope. So what happens is that we're using one x explanatory variable, so we're plugging in just some x that we're wondering about to predict what y hat might be. So we're using one x to come up with what we think y would be. Well, multiple regression is just that. Instead of doing simple regression where we're using one x explanatory variable to predict y hat, we're using multiple x explanatory variables to predict the y hat response variable. So what the equation of that, what the formula for that's going to look like is y hat equals b naught plus b1x like we did before, but because we have multiple x's involved, instead of just b1 times x, we say b1 times x1 plus b2 times x2 plus b3 times x3. For however many x variables we're using to predict y, we just keep doing b1 times x1, b2 times x2, so on and so forth. And so just a quick example that we'll give to wrap everything up, make this a pretty short video, is let's say I'm trying to use multiple dimensions to decide what the price of a house should be. So there's lots of variables that go into that. It's like the number of bedrooms, number of bathrooms, the square footage of the house, and you can even think about other things like, okay, does it have a garage? Is it in a certain school zone? And just many other aspects affect the price of a house. So if I wanted to come up with a model to help predict the price of the house, I want to include as many relevant variables that I think you could use to help give me a better idea of all the aspects that affect the price of my house. So for instance, let's say that this is your line of best fit detailing how you should price a house. So we have 5,000, that's just going to be our y-intercept, it's just a constant value, our b naught, plus 12,500 x1. And let's say that this right here represents the number of bedrooms. So essentially for every extra bedroom you have for your house, you multiply that by 12,500. And so each additional bedroom gives you another $12,500 onto the price of your home. With the number of bathrooms, each additional bathroom adds 5,000 onto the price of your home. You're just plugging in the number of bathrooms for x2. And then the square footage for each square foot that you have, it's going to increase the price of your house by another 40. So just as an example, let's say that this is our model, and we have a 2-bedroom, 1-bathroom house as 2,500 square feet. And we're wondering how much it costs based on this model. Well, all you do, knowing that this is the formula set up and that each of these variables pertain to number of bedrooms, number of bathrooms, and square footage, you're just going to plug in 2 bedrooms for the number of bedrooms, 1 bathroom for the number of bathrooms, and the number of square feet for the number of square feet. And so it's 5,000 plus 12,500 times 2 plus 5,000 times 1 plus 40 times 2,500. You solve for that equation, you get $135,000, and that's going to be the price of your home. So I think that about wraps it up as far as the overview of multiple regression. What you might want to stick around for, though, is that oftentimes you might get an Excel output or a Minitab output that you have information that data was run on. So through the program, through Excel or through Minitab, they take that information and they turn it into the line of best fit formula, where it's a really particular output they give you where there's a lot of different rows and columns and labels you may or may not understand, and you can use those outputs to actually come up with what your line of best fit formula was. So stick around for that video. I'll put the link in the description for it so you can see how you read that Minitab output or your Excel output to come up with that equation. But for right now, that's just the concept of multiple regression. So thank you for watching, and I hope that helped.